Okay. So let's do our first day of conics. It's not really our first day though, right? We've been doing conics. You just haven't known that you were doing conics. So now we're going to look at all of it together as soon as Malik puts his phone away. Yes. Thank you. If I see it again, I'm taking it. Alrighty. So conics, any figure that can be obtained by slicing a double cone. So we talked about this yesterday. So if you slice a double cone like this one, straight across, you're going to get a circle. At an angle, you're going to get an ellipse. At an angle that doesn't go all the way through the cone, you're going to get a parabola. And if you add an angle that goes straight through the top and the bottom, you're going to get a hyperbola. And we learned that all of those equations are related, right? Okay. So students will discover the formula for an ellipse and hyperbola, and I already kind of gave it away yesterday. Okay, so talk with your table groups. What pieces of information in that equation match to that graph and why? Go. Okay, so I'm hearing excellent conversations. I'm just going to change this equation just a little bit, and for those of you that were just a little bit reluctant to answer, it should come clear to you right now. Is that better? Does that pretty much clear it all up? So there is no shift on the x-axis, right, because of the 0. There is no horizontal shift. There is no vertical shift. Therefore, that's why our center is at 0, 0, correct? So on the horizontal axis, and I'm going to call this the major axis. We're going to call this one the major axis. So on the major axis, I'm actually going out 1, 2, 3, 4, 5, 6, 7 in each direction. Let's pause. All right, so that's my major axis, and I'm going 7 units in each direction. This is my minor axis, and I'm going 2 in each direction. Now, why in the world would I call this one my major axis and this one my minor axis? Because the major one is the one that's wider, right? And the minor one. Could we switch it? Yeah, it could be switched, right? But the important part is that going horizontally is always going to be with the x, and going vertically is always going to be with the y. Make sense? Hold on one second. Yes? What if there's a 2 in front of the x squared? Then you would have to reduce it right here. You'd have to reduce it first, because it has to be in this form right here. It can't have a coefficient in front of it. And we'll see that, and you'll reduce it, and then you'll know what's in the denominator. Aaron? I would have a bigger number here. If this number is bigger, then that turns into the major axis, right? What if, I have a question for you, and I hate when I do stuff like this. You know, let's just copy this page, so that's a duplicated page, and I'm going to change it to 7 squared. Yeah, what happens when I change it to 7 squared? It's a circle, right? It would be out 1, 2, 3, 4, 5, 6, 7, like this. It'd be a perfect circle. And, which you guys learned yesterday, and darker. Okay, it would become a circle. And when it becomes a circle, I can write it a different way. Which I hope it doesn't make you guys, so this wouldn't be a major or minor, right? It wouldn't be major or minor. And I kind of want to get rid of this one here, because I don't want anybody to get confused. And I could have rewritten it like this. X squared plus y squared equals 49. And the reason I can put it on this side is that they're both the same. I can write it either way. I can put the 49 underneath each one of them. I can put it over here, or I can write it underneath 49 equals 1. These two things are exactly the same. Okay, so now we're talking, we have an ellipse. This is written in an ellipse form, only it has no major or no minor because they're the same. Okay, yes. King. We're not gonna deal with any of those. We're just gonna deal with, it would have to deal with, I don't even know the answer to the question, exactly what the equation would be, but we're going to be able to investigate that on Thursday, because we're going to do a Desmos project. Okay? So you guys are going to be able to manipulate equations in that way. Okay, yes. What does the 1 have to do with it? Well, when you divide both sides by 49, you get 1. Right? So if I were to show you, this is back in a few years ago when we didn't have Common Core, teachers just gave students these formulas right here. Are you curious? So these were the formulas. So a circle would be x minus h squared plus y minus k squared equals r squared. And then an ellipse would be x minus h squared over a squared plus y minus k squared over b squared equals 1. And then a hyperbola, which I think I gave away yesterday. What's the only difference with the hyperbola? What? I can't hear you. They split apart, you're right. But what's different with the equation? It's negative. Minus y minus k squared over b squared. Yeah, the only difference is hyperbola has a negative sign. This one has. It's always going to be 1. Alrighty, are we ready? King, whatever it is, put it away. All right, there's a different one. Right? Do you see how that changed? So now I've got the major is with the y-axis, right? And the minor is with the x-axis. I could rewrite it as x minus 0 squared over 3 squared plus y minus 0 squared over 7 squared. Can I tell you guys what the number 1 error is going to be on the quiz? Would you like to know? I will tell you right now. This is going to be the number 1 error. Quiz and test, even though I'm going to show it to you. X squared over 4 plus y squared over 9 equals 1. This will be the number 1 error. So my center is at 0, 0. My major axis is this one, which is 3 squared, right? Which is up 3. 1, 2, 3. 1, 2, 3. Can you guess what the major error is going to be? It's going to be 4 that way. Students, for some reason, I don't know why, will forget that this is 2 squared instead of 4, right? And they're going to go out 4. And I don't know why that is. But that is going to be the number 1 error, I guarantee you. And I know because I've done this and I've taught it many times. It's 2. You're only going out 2. I think it's because the number 4 is small and you think, oh, I'm just going to go 4 out in this way. You forget. So I'm telling you now. Telling you now, don't forget, okay? Alrighty. Okay. When's the quiz? It won't be until after we come back from Thanksgiving. Do you guys want to discuss that? Okay, so what we're going to do this week is we're going to do this, and then I have a second day of Conics where it's in standard form, which is that form where you have to actually complete the square to get it into the form we want it. So it's the same information, just we're working with it with completing the square. And then just like with the circle one, you had to complete the square to get the equation. And then Thursday and Friday we're going to do a Conics project. I'm going to give you the whole 2 days in class, and if you don't finish it, it's homework over Thanksgiving break. But basically you have to come up with 10 equations to make a picture on Desmos using Conics. You have to use one of each of the Conics. I'll give you examples. Okay, so we'll come up with a rough draft. You'll have to do it on Desmos, and we'll make, like, these are Conics projects right here. I mean, these aren't Conics, these are linear projects, but they're done on Desmos. That's what we're going to do. And then when we get back, cap that marker, please. Then when we get back from break, we're going to do a couple days of systems of equations. So systems are like a line and a circle, where do they meet? A parabola and an ellipse, where do they meet? Like being able to draw them. That's just more review, right? We're still doing the same thing, no different. And then so that'll be 2 days of that. Wednesday would be the group quiz. Thursday would be the review, and Friday would be the test. Okay? Yes, Kane. I can't hear you. Guys, put the rulers away. Yes, you are. I'm glad you recognize that. Kane? Thursday and Friday, all we're going to be doing is a project. I want to, if you're on it, and you should be able to do your rough draft on Thursday, and Friday you should be able to get all that entered into the computer and make sure it matches your rough draft and be done if you stay on task. 2 days should be plenty. If you're messing around and not using your time wisely, it could take you hours to do it. But 2 hours should be enough if you're really working. Okay? Alrighty. I shouldn't have been recording all of that. All right, now let's go work backwards. Can you guys write the equation for me? I think you can. Get your whiteboards out. Let's do this. Okay, so let's do the center first. So the center of this is over 1, 2, 3. So that's x minus 3, right? And down 2. So that's y plus 2. That's our center. If we were talking parabola, that would be our vertex, right? Same thing, center, vertex, same exact thing. Then, where you guys went wrong, some of you, was I'm going to go out on the x-axis 1, 2, 3, 1, 2, 3, 4. That's 4 squared, which is 16. Or you could have written 4 squared. Then, that would be my major axis, because this one is my minor axis, because it's squishy, right? This is longer, this is shorter, for lack of a better word. 1, 2, 3. So this is going to be 3 squared, or 9. You could have written 3 squared if you wanted to. You kind of have to pick one. If you want to write squares, you leave it as squares. If you want to write it simplified, simplify it. Yes, Kane? Nope. I think that if you write, there were some people that had 4 squared and 3. Like, you have to pick one, or else it's not gonna make any sense. Okay, let's try another one. What else do I have in here? We've got plenty of time. Let's do it. See if we can get 100% on this one. One. Recording. All right, so this time my major axis, let's do my vertex first, vertex or center. So my center is at 1, 2, 3, 4. I went to the left 4 on the x-axis, so that's x plus 4. Can somebody give me a good explanation of why it says plus instead of minus when we went in the negative direction? It's kind of like absolute value. Well, what we're really doing is we're trying to get back to the center, which is what? What's the center? 0. So if I'm trying to get back to the center, which is 0, I want to get back to equaling. Please stop talking. If I want to get back to the center, which is 0, I want to be equal to 0. Then it becomes x equals negative 4. So it's like the shift. All right. I want to say that one more time. Then on the y-axis, I'm not going up or down, so this is just y, or y minus 0. Then my major axis happens to be on the y-axis, right? So my major is up 1, 2, 3, 4, 5, 6. 6 squared is 36. And my minor axis is over 1, 2. 2 squared is 4. Thumbs up, thumbs down. How are we doing? Okay. All right. Look at this pretty guy. Isn't it pretty? Okay. Let me give you, guys, let me give you some vocab, okay? We still are talking major and minor. I'm waiting. We're still talking major and minor. So on this one, my major is on the x-axis since this is 9, which translates to 3 squared. So we're going out. Let's see, what do I want to, I'll use the blue. So we're going out from the center, 1, 2, 3, in both directions, 1, 2, 3. And then on the y-axis, we have 2 squared, which is up 1, 2, 1, 2. I call this right here, this is my slope box. Do you see how it makes a box with those 4 points that I made? The slope box gives me my asymptotes. Okay, do we all have to say asymptotes together? Say asymptote. I'm going to show you right now. So your asymptote, to be a teenager again. Okay. Yes, let's say it again. Asymptote. You guys are enjoying that way too much. So, this right here and this right here are my asymptotes. Asymptotes. Asymptotes guide things, kind of like an orbit, right? You know how something will orbit the Earth and it just goes around it and it comes back down? It's almost like something that has a force on something. It never touches it, but it guides it, okay? So my asymptotes go right through the corners of this box. Do you see what I mean? So this is where I get one asymptote. This is where I get the other asymptote. And then okay, one more vocabulary word, and then we're going to put all the vocabulary on the board. So I've got a slope box from the major and minor axis, right? I draw my asymptotes, and then depending on which one's major or which one's minor, those are where my branches go. So my branches are guided by those asymptotes. These are called the branches. All right? So, vocab. We have minor. We have major. We have minor. These are both axes. We have a center. we have asymptotes, and we have branches. So branches look like this, asymptotes look like this, and my center. All right? Ready to go on? All right. Yeah. If it were positive, it would be an ellipse. I don't know how to answer that question. You're given an equation. You'll see it tomorrow. You're given an equation, and through the equation, a negative will appear from either the x squared or the y squared. And when you see the when you see that negative sign, it automatically just unfolds itself to being an x squared minus a y squared, or it would be facing inwards, and it would be an ellipse. The equation. Yes. So sometimes you may end up with a negative in front of the x squared. Those are going to switch places, and therefore your branches are going to be up and down rather than side by side. Tomorrow we're going to do it. Tomorrow. I love that you're jumping ahead, but okay. So here's another one. So my major this time is on the y. Now, why with an ellipse do we not change? See how the y has changed places with the x? Why with an ellipse, it doesn't matter which one's bigger. The x squared always comes first. And now all of a sudden they change places. Think about that on your table groups. Why would we have to change places with the x squared and the y squared? All right, in 5, 4, 3, 2, 1. What'd you guys come up with? Malik. What? The branches, now the branches are going to be y squared. Yes. Oh, she's relating the parabolas, how they would change sides. When we had a y squared, we would put all that information on the left side. I like that connection, yes. Kane? It's actually a lot easier answer than you'd think. I could write it this way if I wanted to, but do we normally see things written like that with a negative out in front of like that? Do you know what I mean? So we just naturally switch them, and then I know that since my y is coming first, I now have my branches going vertically rather than horizontally. Because your branches could go vertically even if this number is smaller. Like I could switch these numbers and still put that y squared in front, and it would still be going vertically. I'll give you guys an example. Okay. So I'm going to go ahead and do this one really quick. So I'm going to write the equation. So I'm not at 0, 0 at this point. I'm at -1, -2. So this is going to be, why do I have it so fast? Don't need it that fast. Because I was trying to highlight stuff, kind of. There we go. So I'm over 1, so this is going to be x plus 1. And I'm down 2, so this is going to be y plus 2. My slope box on the x-axis, I'm starting at 0, I go out 1, 2, 3, so this is going to be 3 squared, which is 9. And on my y, I go up 1, 2, so that's going to be 2 squared, which is 4. Questions? We're going to do that next. I believe we're going there next. Yes, let's do this one. Let's work. Okay. I'll come back to this. I'll come back this. Let's do this one. Okay, so this is definitely a hyperbola. I know it's a hyperbola because I have a negative sign right here. So the first thing I'm going to do is I'm going to make sure I find my center. So my center is right here. It's 3, but it's going to be -2. So my center is at 3, -2. So I go over 1, 2, 3, -2. I know I have a major axis is 25. I'm going to do this in blue. Major axis is going to be 5 because this is 5 squared. I need you guys to stop talking back there, okay? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then this one would be 2. So up 2, down 2. There's my slope box. Let's do it in red. So here's my slope box. Do you see how I find it? There's my slope box. Now I just need asymptotes. My asymptotes go through the corners of my slope box. That wasn't very good. I need to fix that. A little bit better. We'll just leave it. It's good enough. And then my other one, it's easier to draw them from the corners and then move them. There we go. So there's my asymptotes. The last thing I ask myself is where my branch is going to be located. My branch is going to be located here on the x-axis horizontally, or are they going to be vertically? Because they're going to be horizontally because of not the asymptotes, I have the x's in front. So since I'm talking about the x's in front, it's positive. The y is actually negative. The x is positive, so my branches are going to be horizontal. So my branches are going to go right here. That's it. They have to touch the point because this is kind of like a vertex. It's like it has dual vertexes, right? But they can never touch the asymptote. Aaron?
So the order of the equation does matter.
Yes, for the hyperbola, but not an ellipse. Only the hyperbola. And the only reason that it matters with the hyperbola is because there's a negative in there. Okay. The only reason. Okay? Alrighty. Alright, there's another one. You guys want to try this one? Thank you. Would you guys like to try this one? Okay, try and graph it. See how you do. First of all, before we do that, let's go back to these. I can do these super quick for you. Then you have some examples. I have this graphic for you. Let's talk about it. This one first, and I'll come back to it. Okay, so this one, what type of conic is this? Why is it a circle? Well, it's not in a fraction form. What I could have written it like this: x squared over 16 plus y minus 2 squared over 16 equals 1. I could have written it like that too, right? But since these major and the minor are both the same, right, Bryce? Then I know that it's a circle, right? Because I'm going to go 4 out on my x, and I'm going to go 4 out on my y. And when you go 4 out in both directions, you make a correct? Yeah. Okay. So I should be able to graph this one really quick. My center is at 0, 2, 0, 2, and I'm going out on my x and y axis 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And there's my circle. Yes, ma'am. Okay, I'm just going to do it for you, and then you can see if we need to still ask me the question. Okay? All right, so I have a center on this one. What type of conic is this? It's an ellipse because these aren't the same, right? It's going to be squishy. It's a squishy circle. Okay, so my center is at -4, -1. So I'm going to be at -4, 1, 2, 3, 4, -1. On my x-axis, I'm going to go out 3. Right? Because 3 squared is 9. So I'm going to go out 1, 2, 3, 1, 2, 3. On my y-axis, I'm going to go out 4. 4 on y. So 1, 2, 3, 4. 1, 2, 3, 4. And then I just, yikes. If this was a negative sign, I'd be making a slope box, asymptotes, and drawing branches. Right? Gino, join us. All right, so I'm going to have you guys try that one. I'm going to pass out your homework. Let's write it down. Let's just have you do it, and then I'll go back to that other graphic. Don't let me forget to go back to that other graphic, okay? So why? Let's make the y squared. If it wasn't squared, what type of conic would this be? It would be a parabola, right? I don't know why it doesn't say squared. I need to fix that in the presentation as well. Good catch, guys. Okay, so I'm going to look at my center to begin with. I'll wait until everybody stops talking so I don't have to talk over everybody else. Thank you. So my center is at 0, 0. I'm here. On my x-axis, I'm going to go up 4. 4 on the x, sorry, not on the x. So that's not up. Barry, do you have something to contribute? 1, 1, 2. But you know that meant I don't want you to. 1, 2, 3, 4. Okay, just making sure that we're on the same page. All right, so that was on the x. Now I'm going to go on the y. I'm going to go, what's the biggest mistake people are going to do? They're going to go 4 instead of 2 on the y. So we're going to go up 2 and down 2. Now I've got a slope box. Why would I call it a slope box? That's where I'm going to go up 2 over 3, up 2 over 3, right? That box creates slope for my asymptotes. That's why I'm calling it a slope box. Alrighty, so that gives me my asymptotes. There's my asymptotes. Let me extend them just a little tiny bit. So after I extend them, are my branches going to be on the x-axis or the y-axis? The x, because I've got x in front. So my branches are right here. These are my favorite to draw. I think they're so fun. Okay, most of you got that right. So you've got your homework in front of you. Get to it. Oh, we were going to go back to this one. This. All right, let me explain this graphic. So it's a flow chart. I need everybody's attention. I'm tired of having to talk to this table right here. So this is a flow chart, okay? So this is what I'm going to ask myself. Are x and y both squared? If they're not, we have a parabola, right? When one of them's squared and one of them isn't, we have a parabola. Do x squared and y squared have the same sign? Well, if they don't, it must be a hyperbola. If one of them's negative, we know it's a hyperbola. Okay? Then, do x squared, oh look at my squares moved. Did x squared and y squared have the same coefficients? So if they don't have the same coefficients, it's an ellipse, right? Because one of them's not stretching more than the other one is. So if they do have the same coefficients or the same denominator, then we know that it's a circle. So you guys can go ahead and use that, bless you, to do your homework. Good job today, guys. I want to see everybody on task, 100%.